Now that we've defined the binary number system, we can take a closer look at how binary is used to represent everything that computers do. Whether it's input, that could be from a keyboard, a touchscreen, a game controller, or output, it could be the text on the screen, the color on the pixels, the sound from a speaker. Pretty much anything that a computer can do eventually will be either translated to or from binary numbers, those zeros and ones. So that sound, that music that's coming out of your Spotify, right, or your Apple Music, that's actually zeros and ones. That's read as zeros and ones by the computer before it's translated into useful information, right, that humans can understand. So all these different types of data have different systems to translate zeros and ones into useful information. We'll take a look at some examples. But again, the language of computers is binary. That's the only language that they understand, zeros and ones. Now, the more information you're trying to represent, the more binary digits you're going to need. For example, as your numbers get bigger in the decimal system, right, from 1,000, you have 4 digits, to 1 million, you have 9 digits. Well, the same goes for binary numbers. Now, because with binary, you're only working with two fingers, basically, right? You're only having your 0 and your 1 before you move on to the next digit. It's going to take a lot more binary digits, right, than the decimal system. One new vocab word we're going to add to our skill set is bit. Bit is actually short for binary digit. It's that word kind of combined. So bit is the smallest unit of data that a computer can read. And remember, binary numbers, it's either going to be a 0 or a 1. For our first example, we'll look at how text can be translated into binary, how it can be represented by those zeros and ones. So let's take the word hi, only two letters. It turns out it takes quite a bit of binary digits or bits to represent this word. So we have various different systems that will turn letters or symbols into numbers. So the letter H, eighth letter in the alphabet, for example, with the ASCII number system, we can convert that letter H into the number eight. Eighth letter in the alphabet, naturally would be the eight. Now, of course, computers can't read the number eight. They can only read zeros and ones. So you have to translate that eight into a binary number. So it's going to take quite a few bits, even though eight is a small number. Remember, when you're working with binary, you're working with two fingers. So the binary representation of the number eight is 010, 01000. There is some math behind this. If you do become a computer science major, you might take something like discrete math, and they actually expect you to learn how to translate to and from binary to the decimal system. There's other systems like the hexadecimal system. So it is possible to do this by hand. Of course, this is an intro class, so we're not going to discuss that. Just know it involves exponents, powers of two, some addition, and so forth. All right, so 8 as a binary number is 010, 01000. So that is what we use to represent the letter H. That's what the H looks like to a computer. This long sequence of zeros and ones. Pretty similar for I. I is the ninth letter of the alphabet, slightly different binary number. So it's going to be 011, 01001 to represent 9, or the ninth letter in the alphabet, because this ASCII number system goes to decimal numbers and then to binary numbers. So the letter H and I together form the word hi. So the word hi can be represented by these two binary numbers put together. But we can represent a lot more than just text with binary, right? Computers can do way, way more than that. Let's take a look at an image. So on the left, we have a very simple image, just black and white. So the less information, the less digits we're going to need. So we have two colors. We have white and we have black. You can think of white as the pixel being on. Pixels, of course, if you zoom into any screen, you'll see these little squares, right? So all these really high definition screens that seem to be able to create curves. Really, if you zoom in, it's just a bunch of little boxes. So with two colors, we can represent the on pixel or the white pixel as 1 and the off pixel or the black pixel as 0, right? There's no light coming out of that pixel. So if we arrange these zeros and ones, we can represent an image. And of course, we can see here on the left, we have a smiley face, right? Using these zeros to outline it. Now, black and white, it gets the job done, right? But most of us, we want to see some color. Uh, we're way, way past the days of black and white TV. color TV's been around forever, for example, we expect there to be some color. In order to do that, well, that's more information, more colors, so we're going to need more binary digits. On the right, we have 4 colors. We have red, orange, yellow, and we have white in the background. So white can be represented by 1, 1. The red could be 0, 0. The orange could be 0, 1. And the yellow could be 1, 0. So again, if you arrange these, you can create an image. Now, of course, this is a very simple image. It's a few concentric circles, if you can call it that, right? Since it looks a little boxy. But we are indeed representing more information. And if you put enough of these digits together, right, you could represent what we're seeing right now on the slide, right? All these different colors, all these different images, um, all these different texts as well. So all of that really is just zeros and ones to the computer. So let's add a few more vocab words to kind of be in the language of technology. So we already know bit is either a 0 or 1. Well, it turns out we have another kind of metric for bits, and that's bytes. So let's take a look at the word high. We already translated it, and we saw that it was 16 bits, so quite long in binary. So 0, 1, 0, 0, 1, 0, 0, 0, that's H. 0, 1, 1, 0, 1, 0, 0, 1, that's I. Altogether, that's high. Well, it turns out 8 bits together is called a byte. So that's a natural grouping that we classify in computers. So the word high would actually be 2 bytes long. Bytes are a useful way to measure how much data this information takes up on your computer. So you might have heard of kilobytes or megabytes or gigabytes. These days, right, we're moving on to terabytes more and more frequently, more commonly. I can tell you the phones back then didn't even get to the gigabytes of memory. Nowadays, we're in the hundreds of gigabytes, right? That's the standard for most smartphones these days. So it turns out those zeros and ones take up space on the computer. And you put enough zeros and ones together, you really 8 of them together, you get a byte. You put enough bytes together, and you start measuring, right, how much space that takes up in memory or in storage. We're going to differentiate those two terms once we get into the hardware parts of a computer. But yeah, there's some different terms here. So we start off at bit, and then eventually we get to byte. That's 8 bits. In between, there's a nibble, kind of a funny name. Once you get to the 1,000 bytes, you get kilobyte. The 1,000 kilobytes, you get a megabyte. 1,000 gigabytes, or sorry, 1,000 megabytes, you get a gigabyte. 1,000 gigabytes, you get a terabyte, and so forth. Now notice these are not exactly 1,000. These are the actual number of bytes for a kilobyte. Now in commercial kind of memory classifications, we get rid of the 24 and we just say 1,000 bytes just for, I guess, simplicity. But just know about 1,000 is going to get you to that next prefix, that next order of capacity. And then down here, we have some really big ones. We have petabyte, exabyte, zettabytes, yottabytes. That's going to be when you're dealing with really big databases, which we'll discuss in this class. You actually get a chance to code some actual databases. Of course, not a real one, right? We'll work with a simulation, but we're going to get familiar with all aspects of computers, which can seem kind of a little bit scary, right, when you're first getting started. But trust me, I've had students that are straight up beginners, barely knew how to use the mouse, and eventually, right, they were publishing um, spreadsheets, presentations. I don't want to give too much away, right? But yeah, you're going to do quite a bit in this class. I'm going to challenge you to know all parts of computers.